Hello, Chemistry 11. This is Mr. Chan. And what I wanted to do today was I wanted to focus on a couple of sort of higher level thinking questions when we're doing empirical and molecular formulas. All right, now these ones, you follow the same processes as what you had learned in the previous two videos. But what I've done is thrown a little twist in each and every one of them. Now, the first one I want you to focus on is, let's say, question numbers 10, 11, and 12. So let's say, for example, question number 10. Cupric chloride, CuCl2, when heated to 100 degrees, is dehydrated. Dehydrated means that water is given off. If 0.235 grams of copper 2 chloride .X H2O gives 0.185 grams of CuCl2 on heating, what's the value of X? Now, so the first thing you might want to think is, what is this little circle mean here, this little black dot? Now, this little black dot is different than what that means in math. Some math teachers use that as multiply. In this case, what it means is that water is attached. Now, if I were to draw a diagram of this, it would probably look something like this. So we have CuCl2, and what we have is attached is like here. It's attached to the compound, but it's not directly included in the formula. Now, the X just tells you how many are attached. An example would be something like this. Let's say CuCl2 is a band. Let's say there's this group that's really popular right now, BTS. Okay, now the water would represent the people that follow that band, and this one is called, they call it the army, the BTS army. That would be like what water represents. They are attached to the group, but they're not actually part of the group. Okay, and that's what that little dot means. So how do we approach this question? Well, this question is very similar to how we did the question up here, where we have mass, mole, and ratio. Notice on the left-hand side, we used carbon, hydrogen, chlorine, which are atoms. So when we set up a question something like this, we do the exact same thing. I'll still use the table. So here, I'll still have the table, and I'll still set up, it'll say, the mass, you have moles. The setup is exactly the same, but instead of using elements like carbon, hydrogen, and oxygen, now what we do is focus on the molecule. So we use CuCl2, and we have H2O. Now, how do you determine the mass? Is exactly the same. In this case, the question gives us 0.185 grams of CuCl2. So here would be 0.185. And how do we figure out the amount of water? Is, notice we started off with 0.235 grams of this entire compound. So to figure out how much water, what we would use is, this one would be 0.050. How do we calculate the moles? Similar to what you've done before. So if we did 0.185 grams, you divide it by the molar mass of copper, 5 and 35.5 times 2. Okay, this would be like 134.5. Water would be 0.050 divided by 18.0 grams, ... Pretty straightforward. So this is one variation of empirical and molecular formula that is just slightly different than what we gave you in the lesson. The second one I wanted to focus on is a little bit more challenging. What we did in last day's videos is we broke everything down into things like molecular formula, and empirical formula and percent composition. Okay, how can we incorporate that into one question? Well, let me give you a sample question that you can take a look at. It says here, it says a 17.471 gram sample of trioxane, a compound with only carbon, hydrogen, and oxygen, is burned completely in oxygen to produce 10.477 grams of water and 25.62 grams of carbon dioxide. Calculate the empirical formula of the trioxane. Now, when you first look at this question, you might say, how am I supposed to do that? I don't know the mass. So because I don't know the mass, how can I start this? So what you can do is you can take a look. It says, calculate the mass of carbon and hydrogen from the products. So in this case, what you have is you have carbon. So how do we get the carbon? So here, the 25.62 came from the mass of carbon dioxide. Now, what is this 12 divided by 44.0? This was from our lesson in percentage composition. So here is the percent of carbon in CO2. Now we are able to determine that in carbon dioxide, out of the 25.612 grams of carbon dioxide, 6.9899 was actually made up of carbon. We do the same process with hydrogen, the 10.477 grams of water out of, and then you calculate the percent composition of hydrogen in water, and we get a value of 1.172. Now, but you might say, Mr. Chan, we've got the carbon, we've got the hydrogen. How about the oxygen in the original sample? So if we take the 17.471 grams of trioxane and we subtract the amount of carbon, subtract the amount of hydrogen, what we have is we have 9.309 grams of oxygen in the original example. Now we know our three masses. Then we can start again finding the mass, finding the mole, finding the ratios, and we can get our answers. Okay, this is a little bit more challenging, but if you are able to understand how do you process to get these numbers, okay, that means that you are pretty solid in this particular section of the mole calculations. All right, if you are having trouble, by all means, come and see me, and we can I can walk you through this in a little bit more detail. All right, folks, thank you very much. Have a good day. Bye-bye.